The yttrium is the first of the D-block elements in the fifth period of the periodic table, located between scandium and zirconium. This rare metal is a transition metal and is less electronegative than lutetium. Yttrium has several isotopes. The most stable is yttrium 89. However, the other isotopes are unstable. Among the rare earth elements, yttrium behaves chemically in the same way as lanthanide metals. Yttrium oxides are manufactured in a variety of methods. They can be manufactured in solutions, powders, or denser pellets. Yttrium is an important ingredient in a superconductor. This means that it can keep an electric current going for long periods of time without being cooled. But it is not very easy to work with at extremely high temperatures. Yttrium is very difficult to extract. There are some methods that can be used to isolate yttrium, but they can be very expensive. The discovery of yttrium in the 18th century was a fascinating event. It is known that it was isolated and analyzed by chemists in the early 19th century, but how exactly was it discovered? In 1787, Army Lieutenant Carl Axel Arrhenius found a strange coal-like substance in a quarry in Ytterby, Sweden. He sent the sample to a chemist in Finland for analysis. Arrhenius believed that he had discovered a new mineral. His sample contained yttrium oxide. But the sample could not be reduced with charcoal. Arrhenius passed the sample to Johan Gadolin of the University of Abo in Finland. Gadolin subsequently found a new oxide in the Arrhenius sample. Gadolin named the new element yttrium and published a paper about the discovery. Yttrium is a rare earth element that is found in various minerals. Yttrium oxides are mainly manufactured in China. However, it does not normally appear in human tissue. It is commercially extracted from bastnäsite. In some regions of the solar system, it is more abundant, and it can be found in rocks brought back from the moon. The abundance varies among regions, but is estimated to range from 28 to 70 parts per million. This element is found in monazite, which is a variety of soil that contains rare earth elements. This mineral is found in many different places throughout the world. It is a silvery and soft metallic transition metal. Yttrium's magnetic susceptibility is temperature independent. Instead, it is added to other materials to make them more resistant to oxidation and wear. Yttrium is a soft, silvery white metal with a metallic luster. It is an intermediate conductor of electricity and heat. A common form of yttrium is the phosphor. Yttrium has a high latent heat of vaporization of 363 kilojoules per mole and is very toxic. Some yttrium compounds are radioactive. Like many other rare earth elements, yttrium has an electronegativity value of 1.22. This means that the number of electrons that are able to occupy orbitals increases when a negative ion forms. The atomic radius of yttrium is 212 pm. Its melting point is 1526 degrees Celsius. Yttrium can be dissolved in acids to produce yttrium halides. The most important compound of yttrium is yttrium oxide, or Y2O3. This oxide is superconducting, meaning that it can conduct electricity without any resistance at temperatures below -178 degrees Celsius. However, it can become unstable in air at lower temperatures, and can even ignite if heated. In order to keep yttrium in a superconducting state, it is doped with erbium or europium. Yttrium is found widespread use in many applications. The applications include a wide range of uses from healthcare to consumer electronics. Until recently, it was the primary component of television sets. There are numerous benefits of using yttrium, especially when it comes to its use in phosphors. These phosphors are used in television sets and computer monitors. They provide white and gray colors. Aside from television and computer monitors, yttrium is also used in optical coatings. Its oxide is widely used in ceramics and insulators. One of the most popular applications for yttrium is in the form of nanoparticles. These particles are often used in bioimaging, anti-cancer therapy, and photodynamic therapies. Yttrium oxide nanoparticles have also been found to inhibit bacterial cell growth. Yttrium is often used to make high-temperature superconductors such as yttrium barium copper oxide or YBCO. This material can operate at temperatures of over 90 Kelvin. It is a chemical that has several applications. One of its most common uses is in the production of phosphors. These phosphors are used to create the red coloration found in televisions and color television sets. Another application is in the manufacture of lasers. Yttrium is used in a variety of alloys, including those that increase the strength of metals and reduce corrosion. It is also used as a catalyst for polymerization, such as ethylene polymerization. In addition, yttrium is widely used in jet engine coatings. Despite its importance in industry, it is rarely used on its own.